We're back. I'm going to talk about observational research versus true experiments. We've all done observational research. We've all gone through and seen where people just walked around and recorded what somebody else was doing. That's called observational research. People watching. This is something that everybody's participated in. Might not be as systematic as somebody who's doing ethnography, but observational research looks at people in their natural environment and doesn't manipulate anything about them. Now that's different from what most of the time we're going to be studying with statistics, because all you would use in observational research is descriptive statistics. That'll only be the first part of our class mathematically. Much of what we're going to be studying is inferential statistics, and that's used in true experiments, not naturalistic observation or parameter estimation. That's where we use a small sample to sort of project what the parameters are of the population. But to do true inferential statistics, we're going to need to look at experimentation. Experimentation, a true experiment, is one where the researcher, whoever the researcher is interested in solving this question, actively changes something about a natural environment. So let's say I have two classes, right? I've got you, and then I have this other Psychology 330 class. But let's say that the other class gets no videos, they only get the PowerPoints. Do you think that would make a difference? You see, in that situation, I am implementing a change. I'm manipulating a variable. And that's what the course method or the content that's available to the students. In that situation, it's a true experiment because I'm going to measure both on the same measurement, and I'm doing something different to one versus the other. That's a manipulation. Manipulation, not a bad thing, but I'm changing something about the experience of these two groups of people that would otherwise be the same. If I was doing naturalistic observation, I'd try to find a professor that did not do videos and only use PowerPoints for their class learning, and then I would compare their student scores to, say, students who had a professor that did videos and PowerPoint, to see, does this make any difference? Is this something that's important for students learning stats, or do I not need to waste all my time doing these videos? The problem with that line, and this is something you'll find more in research methods, is critiquing methodology, is that if I just do naturalistic observation, what if that teacher has way better PowerPoints than I do? And so it offsets the actual difference that exists. I might miss a difference that exists, that it is important to do videos and PowerPoints because that guy's PowerPoints or that lady's PowerPoints are so much better than mine that the student scores come up, and so I don't see a difference where one actually exists if all things else were equal. Or as they say in economics, ceteris paribus, that all else is equal and all you've changed is this one variable. That's the idea of a true experiment. In naturalistic observation, obviously, if we don't manipulate something, we have to find where those things do exist, right? So if you think about one of the naturalistic observations we'll see in the coming months, is distance learning as effective as learning face-to-face for elementary school students? We didn't design this experiment. No, there was no grand experimenter out there. NIH didn't fund something to say, you know what, let's shut down all school instruction and we'll just see how online learning does. They wouldn't have gotten the approval for that. People would have revolted. So now what we have is an opportunity with naturalistic observation to do a kind of experimentation, but we actually don't get to manipulate anything. We're just going to compare students, say, in the beginning part of this year, where they're doing online education, with students who learned last year face-to-face. This is a perfect natural experiment, but it's not a true experiment because we're not saying, okay, take half of the students in this class and put them face-to-face and half of the students in this class and make them go online. Also, you can't just take the students whose parents chose to have them stay online if we return to normal face-to-face instruction and do that, because there might be a different outcome from those two groups. They're not representative of the total population. They're a bias in the groups. These types of studies are going to be correlational studies. We'll say, how well did this correlate with, say, outcomes this way? Or how well did this correlate? Was it a statistically significant correlation? Or was it not a difference between these two? So that will be interesting to find out when we find true experiments in the future. The way I describe a true experiment is that they are meant to determine if a change in one entity, or a variable, affects the levels or exacts a change in another entity that's a separate variable. Now we'll talk about these two variables. One, let me get something to write with. One is called the independent variable. Independent. I didn't do that well. I might have to find something to erase this with. Independent variable. So the independent variable is referred to as the IV, not 4, that's not a Roman numeral, I didn't put ch. The independent variable is the one that I'm manipulating. So in that sense, if I could work all the magic, I could say, okay, I want half the students to do distance learning and half the students to go back face-to-face normally. If I could do that, that might allow me to answer the question, is one of these two modes of teaching better than the other, or are they not different at all? But I'd have to measure students on the same exact measurement, and so that one is called the dependent measurement, the dependent variable. Dependent variable. The dependent variable, or DV, is the thing that we measure across all groups. So let's say I had a group that goes all online, one that comes back hybrid, and one that is fully face-to-face learning. I could have 3 versions of the independent variable. There could be 3 treatments, right? If I had a drug and I gave you 5 milligrams, 10 milligrams, or 15 milligrams, there could be 3 different things. But I have to measure all those groups on the same dependent variable. The dependent variable is something that's measured the same across all groups. So in this sense, if I have students that are face-to-face, hybrid, where they mix the distance and face-to-face, and the ones that are exclusively online for distance education, I'd have to measure them all with a standardized test, or all with a measurement, right? What if I said, okay, we're gonna not only look at sort of academic outcomes, we'll look at psychological outcomes. How well did they do socially? How well did they do emotionally? I have to measure all 3 groups on the same thing to see, are there changes in modality of instruction, face-to-face, hybrid, exclusively online? Are those the things that make a difference in this particular academic outcome, social outcome, emotional, psychological outcome? So the dependent variable we measure across all groups. The difference is that they might have some differences in the independent variable. Now, for it to be a true experiment, I need to be able to pick who goes into which one, and I need to randomize it so that all people that I'm studying, the entire population, that everybody's just as likely to go into any one of these groups of the independent variable. That's not what happens in the naturalistic observation, right? So when these educational researchers at the end of this COVID virus go back and they analyze the data to say how well was online education for our students versus face-to-face instruction, they're going to make some correlational claims, but they're not going to be able to say a causal claim. In order to make a causal claim, you need to be able to manipulate and randomly assign people into each of these different types of independent variable factors. So you'd need to, I want my kids to go back face-to-face. That's just my desire. But if my kids were a part of a true experiment, I would have to say, okay, they can be in the experiment and they might randomly be assigned to the online only learning. So that's where it's kind of difficult to run true experiments, because you have to get the participants, or somebody who gives consent for the participants, you have to get them to agree that they could be any one of the conditions. If you think about it for like a treatment of like a drug thing, you've got COVID and you're now the doctor said, hey, do you want to be a part of this experimental treatment? You go, yes. And they say, well, but we're going to have a treatment group with this drug we think works to treat it, and we're going to have this control group. And you say, well, what does that mean, this control group? You see, in an independent variable, we're going to have one group that gets the thing that we want to know, does it make a difference on outcomes of COVID? But we also have to give people not that treatment, the control group. So you have to have the group that gets the treatment and have the group that thinks they might be getting the treatment that isn't, the placebo group. You have to randomly assign them. You can't say, I really want this experimental treatment, so please put me in the treatment group. That doesn't make any sense, because that's going to change what's going on with your body, and it's going to change how you metabolize whatever medicine you get, treatment you get. And so you have to be able to randomize who goes into what group. And so if you sign up for an experiment like that, you have to recognize, many of you are healthy out there. Maybe you're going to sign up for the vaccination experiments and you say, look, I don't have COVID, I've been tested, but I want to test to see if there's an effective vaccine. Part of the testing is going to say, hey, half of you, we're going to stick a needle in your arm and push it in there, but you're not actually getting the vaccine that we're experimenting on, because we need to compare you as a group to the group that gets the active vaccine to say, is this an effective medication? Is this something that's going to increase immunization towards, herd immunity? That's a real difficult thing with true experiments. With naturalistic observation, you could just say, okay, there's going to be people that don't get the vaccine, and then we'll give vaccine to a bunch of people, and we'll just say, are those groups different? Problem with that is that you can't claim that the vaccine causes whatever treatment outcome effect you want. You could just say it's correlated, and we'll get to that at the end of the class, but it doesn't mean that it causes immunization to increase. It just means that it's correlated with it, which is there is a relationship. Okay, how big is that relationship? How important? Those are things that we will discuss in the future. All right. I used to teach PSYC labs where we'd cut sheep brains and cow eyes and do fun stuff like that. And this is an example from a section like that. So if I wanted to know which lab exercise was the most helpful, I could divide my class into two sections, right? The right side of the class or the left side of the class. And I would give them a different style, right? One, I would say, okay, we're going to do the normal lab assignment, but then this side, we're going to do a lab assignment, and it's going to have flashier movies and cool videos and, celebrity YouTube influencers talking about how to dissect the cow eye. And if I wanted to see which one of those was better, I would have to measure both of them on the same test, the same dependent variable. Despite the fact that this group got the normal lab experiment, this group got this sort of celebrity influencer enhanced one, I'd have to measure both on the same lab exam to say whether or not that worked to increase or change scores. Another example, let's say you desire a relationship. They are great. They're very important for people. Let's say you want to get into a relationship, and so you want to know, well, before I sign up for some sort of online dating thing, which one's the best? You might figure out, let's look at the statistics on, say, eHarmony versus Match versus Tinder. Is Tinder? I forget. I'm sorry. I'm an old person. To see who's better at actually getting long-term matches. And if you did that, you could compare them on an outcome, say the length of the average relationship. Right? The difference would be which website. And then you could say, well, do they have a difference in the relationships? The longevity of those relationships. And if that's what you're desiring, then you could pick which one you go to based on a difference in the dependent variable, the length of the relationship, if it was statistically significant across those different ones. In fact, eHarmony as a website is designed to utilize statistics to try and promote that. So they kind of have an unfair advantage that they're using science and statistics about psychology and relationships to increase the longevity of their connections that they make on eHarmony.com. I think Match.com has also sort of implemented those statistics to make it seem like there's longer relationships. But think about this. This is something I don't. Do you think it's a benefit to eHarmony or Match.com if you find a loving relationship that's long-term and committed? Because then you won't need Match.com or eHarmony anymore. All of these websites, Facebook, Instagram, Yelp, they're all designed to get you to keep coming back. So they're probably not setting you up for the long term. Just think about that. I'm going to get canceled by these good thing I don't have any online dating apps. I would be canceled by them. They would make me go away. All right.